This is now the fourth part of the section 4.5, graphs of sines and cosines. In this section, we're going to look at transformations of sine and cosine graph, focusing on producing vertical shifts and vertical stretches. Okay. So just like we did with the parabolas in the previous video, we are going to look at shifting sines and cosines around. So I'm going to start with the sine curve here, y equals sine x. I should point out that if you're doing this with your calculator, you need to be very careful as to what mode your calculator is in. When I look at a sine curve and see one cycle of the sine curve happening in just over 6, so that is a period equaling 2 pi, I'm in radians. If you were in degrees, then the period of a sine curve is 360 degrees. So you'd have to have your window showing all the way from 0 to 360 in the x direction just to see one cycle of the graph. Generally, the default on your calculator is to show from -10 to 10, and so you would see very little of the sine graph if you were trying to graph y equals sine x, where x was in degrees. So from the point of view of graphing these things, you want to have your calculator in radian mode. Okay. The default here in live math that I'm using to do this demonstration is radian mode. So y equals sine x. You can see it right there. Notice it gets as high as 1 and it goes down as low as -1. I can drag this over and you see that it continues on and on and on, repeating every 2 pi. So let's get back to the middle here. What I want to do is I want to do like we did with the parabolas. So I want to take y equals sine x. Actually, I'm going to leave the black curve there and see what happens when I say sine x plus 2. Live math will do this to you. You try to type things in and it tries to interpret it right away, and you get the S typed in and it says, hey, I don't know what S is. Say, just hold your horses. Type in everything you want, then click on the graph again, and there you go. So what has happened by changing from sine x to sine x plus 2? Notice the plus 2 is outside of the parentheses. So for the same value of x that I plug in both here to calculate the y for the black curve, and plug in there to calculate the y for the blue curve, we first of all calculate sine x. Then, for the blue curve, we add 2 onto that value before making it the y value. So for the same input, the y values on the blue graph are always 2 bigger than the y values on the black graph. Hence, the graph just gets shifted up. Change the 2 to a 3, and it gets shifted up a little more. Change the 3 to a 4, and it goes even more. If rather than adding 4, we subtracted 4, it of course gets shifted down. You can see the original curve in black, and then the blue curve being the transformed curve. Right? Change the equation by adding a constant to your function. The graph changes by shifting up or down. If you're adding a positive constant, it shifts up. Of course, if you're adding a negative constant, it shifts down. So there's the sine curve. It's very similar with the cosine curve. So let's see if I can get this to change. It doesn't want to do that. Let's see. Change the sine to cosine. And change this sine to cosine. And take a look. So now the black curve is the cosine curve, and the blue curve is the cosine of x minus 4. Shifted down 4. Okay. Now, again, there's no difference between shifting for x squared, shifting for sine x, shifting for cosine x. If you add a constant to the function, the graph shifts by whatever you add. Shifts vertically up and down in the y direction, right? Now, the next thing I want to look at is vertical stretches. Rather than adding something onto the function, I want to multiply something by the function. So let's get rid of that. So now the black and the blue curve are in the same place. And what I want to do now is I want to, out in front, multiply by a constant. So let's multiply by a 2. Okay. The blue curve now still has the same period. Notice starting at 0, you go down, starting at x equals 0, you're at your highest point, you go down to the lowest point, back to the highest point, in just over 6. I don't know if you can see there's a little 5 right there. So the next block would be 6. So in 2 pi, you go from 0. So you go from the top of your curve back to the bottom, back to the top again. One cycle happens from 0 to 2 pi. The period is still 2 pi. We haven't changed anything there. But what we've done is for the same value of x that you plug in both places, you first evaluate the cosine of x. Then for the blue curve, you multiply that value by 2 before making it the y. So the y values for the blue curve will be always twice as big as the y values for the black curve for the same input x. The result in the graph is that the blue curve is twice as tall as the black curve. The terminology that we use is amplitude. Where the first one had amplitude 1, the black one, the blue curve now has amplitude 2. Amplitude is the difference between the center and the highest point. If you look completely from the highest point to the lowest point on the black curve, that's a difference of 2. But from the center line up to the highest point is a distance of 1, amplitude 1. For the blue curve, from the highest to the lowest is a total of 4, right? Because you go up from +2 to -2, that's a difference of 4. But if you look just from the center to the highest point, then that's 2, amplitude 2. You can probably predict what happens if I change that 2 and turn it into a 3. The amplitude now becomes 3. Everything is being scaled vertically, scaled in the y direction by a factor of 3. Outside the function, whether you add something onto the function or whether you multiply the function by a constant, you've done it after evaluating. You plugged in a value of x, you figured out the function value, figured out what cosine x is, and then you're doing something to it. If you're adding onto it, the graph shifts. If you're multiplying, the graph stretches in the y direction. You can get any amplitude you want by just putting that number here. If I want amplitude 10, I've got amplitude 10, 10 times the cosine of x. Likewise, this would work the same with sine x. Picture just moves, well, it looks like it moves over because sine and cosine are very similar shaped graphs. Sine x there. Let's make this a sine x. And draw the graph. See, now it's going through the origin. The high point is when x is pi over 2, back to 0 at pi. Low point at 3 pi over 2, back to 0 at 2 pi. Okay. Big amplitude, 10. Let's come back to a smaller amplitude. Let's say amplitude 3. But now I want to say, what if I make that a -3? Rather than multiplying by a positive constant, multiply by a negative constant. Well, the result is the graph gets turned upside down. Yes, it gets scaled by a factor of 3, but it also becomes negative. So we're plugging in the same value of x here and there. You first evaluate the sine. For the black curve, the y value is just the sine of x. For the blue curve, after you evaluate the sine of x, you multiply that result by -3. So the y values on the blue curve are always -3 times the y values on the black curve. Hence, it's taller, has amplitude 3 now, but it's also upside down because where the black curve had positive y values, the blue curve has negative y values, and vice versa. When the black was negative, the blue was positive. So multiplying by a constant changes the amplitude of the sine curve or the cosine curve. Multiplying by a negative constant also turns the whole thing upside down. Okay, you could do both, multiplying and shifting. So I have right now a sine curve multiplied by -3. I can then add on to that constant, let's say 2. So this is amplitude 3 upside down, shifted up 2. So notice where amplitude 3 would go as high as 3 and down as low as -3. When you shift it up 2, it now goes as high as 3 plus 2 up to 5 and goes down as low as -3 plus 2, which is -1. So the low spots are at a y value of -1 and the high spots are at a y value of 5. Notice though, right in the middle, through the midline here, the average between -1 and 5 is 2. That midline, halfway between the highest and the lowest point, will always be the vertical shift. We'll be able to see that shift very clearly by just finding where that midline is. Once you know that midline, you can find the amplitude by saying from the middle y value, how far up do we go? Well, from the middle y value of 2, you go as high as 5. That's amplitude 3. I can see this is upside down because starting at x equals 0, a normal sine curve would go upwards. This goes down, so it must be upside down sine curve. Hence, I would expect to see a negative sign there. Okay. So either knowing the function, you can figure out what the graph is, or also we'll do some examples where we're looking at the graph, trying to figure out what that function is. That concludes this part of today's lecture.